What's up, guys? In this video, we're going to be talking about one of Maci's special and useful features, and that is locking. Now, in this section, we're going to be talking about locking, unlocking, and even how to view what's currently in the locks, and we'll be talking about hard locking as well. But first off, what do I mean by locking? So Maci offers this built-in feature that kind of gives you a constant-like ability. It's not exactly a constant, but it kind of gives you like a constant-like ability, where it allows you to lock your attribute names and offers a level of protection over them, which can be extremely useful depending on the nature and context of your project or your code. And the first one we're actually going to dig into is just the normal lock. It's just called lock, which is kind of a general lock or soft lock, if you will. And to read the documentation on it, just to give a better or formal understanding, is attribute names that are locked cannot be reassigned to a new value, but a locked attribute name can be deleted or unlocked. If there is an attempt to reassign your attribute name that is currently locked, an exception will be thrown. And in order to lock an attribute name, the attribute names must already exist in order to lock them. You can't lock an attribute name that doesn't already exist, which I think makes perfect sense. And additionally, which we are going to go into as well, if you have an attribute name already locked, you cannot hard lock it. You can't have two locks on one attribute name. You can only have one or the other. At least with the current version of Maci, which is version 1, you cannot have two or more locks on an attribute name. You can only have one or the other. Hopefully that makes some sense, but of course we're going to dig into it. So let's start off by creating an empty Maci data object, and then we'll add an attribute name and a value. So I've gone ahead and created a Maci data object, and then I went ahead and made some attribute names and values, kind of following or exactly following the example that we've had in our little game save data file here. Okay, so now that we've created our data, the first thing I want to show you is what would happen if you reassign that attribute name to a new value. So let's go ahead and just use the money as an example, which would actually be a good candidate for this to protect against. So first, let's just print it. So we see our normal floating point value of 1,000, which is $1,000 in this example. But if I come in here and set data.money to equal, let's just say, let's do 10,000, and then go ahead and print it. You see now I have $10,000. First we print 1,000, we set it to 10,000, and now we print it. It says 10,000 now. So you see how easy that was to set a new value. In fact, we could have actually just set it to none if we wanted to and get none. But you see how simple that was, which is the normal behavior in Python. But what if you actually wanted to protect that attribute name from being reassigned? This is where the lock comes in. So let's go ahead and lock the money attribute name and see what happens before it gets reassigned. So I'm going to go ahead and access my Maci data object. I'm going to access the lock adder. And now let's go ahead and hover over this. So all the lock adder method simply requires is that you pass a string with the attribute name. And as long as it exists, it'll lock it. So let's do that. So I'm going to simply pass money in there. And so now what's going to happen is as soon as I attempt to reassign this, there's going to be an exception thrown. So when I run this, there it is. So we first see the print of money here, which was $1,000. And then right after that, we get an exception. And Maci saying attribute name locked cannot be reassigned. It even tells you which attribute name was locked. And that's really all it takes to simply lock your attribute name from being reassigned to a new value. Now you might be wondering, if I catch this exception, will the value still update? Let's go ahead and try that. Let's actually go ahead and put this up here. We'll put it right there. And then we'll go ahead and do our try block. And we'll just get rid of that for now because we don't really need to see that. And we'll just keep it in the same line. I know that's not proper writing, but we'll just keep it in the same line, and we'll just do pass. And we're just going to capture all exceptions. So right now we're trying to reassign this attribute name, right, to a value. And then once the exception is thrown, we're going to catch it. And then afterwards, we'll get our value, but the value will remain unchanged. So let's go ahead and run this. And when you see this, you see the value has not changed at all, has not updated at all, which is great. And of course, if we remove these, run it again, we get our exception being thrown. But the point is that your value does not get changed. It is completely protected. So that could be extremely useful if you want to protect your attribute name from accidental reassignment. Now you might be wondering, what if at some point in my program I need to update that attribute name to a new value? What can I do? Well, you can simply use the partner function, which is the unlock adder, and it's just as simple as the lock adder was. So if I just type maci data, which is my object, and type unlock adder, it's asking for the same thing, just an attribute name in the form of a string. So if I just type money, and we'll move this down, and then reassign it, this will unlock the attribute name. I could have, some code run, then we unlock it, update it, and then we can relock it if we want to. But let's go ahead and run this, and you see now it was safely unlocked, and then the value is updated to 10,000. And if we were to relock it, nothing really changes, but if we were to retry to reassign it, even if it's the same value, this will throw the exception and block you from doing it, right? But rest assured, we know that the value was updated. If we move this up real quick, we can see 10,000 printed during its time when it was unlocked. So that's how you can actually lock and unlock an attribute name and update it when you need to, and relock it when you need to during the runtime of the code. Now, the next thing I want to show that you might be wondering about is there like a list of attribute names that I can view in order to see what attribute names are actually currently locked? And the answer is yes, there is a method called getLockList in order to view that list of attribute names. So let's just go ahead and remove most of this. Then we're going to go ahead and print. We'll access our maci data object. And if you simply type getLockList and run it, there's no parameters. It simply is going to return a copy of the current list of locked attribute names. And so if I run this, you see currently money is locked. Of course, if I go ahead and lock another attribute, let's try starting score and run this. And now you see that starting score has been added to the list as well. So this is a quick, useful method if you actually want to get a current running list of your locked attribute names inside of your maci data object. Of course, if you unlock an attribute name, it will be removed from the list. Actually, let's just go ahead and copy this. And if I run this and now unlock it, it should just show starting score now. So first it was locked, another one was locked, and then we actually re-unlocked money, or just unlocked money, and now we got our list, and now it's not showing in that list anymore. So hopefully that makes sense, but that is how you simply get a list of your attribute names that are currently locked. So the last part for just locking, we learned how to lock and unlock. You might be wondering, what if I want to delete my attribute name after it's been locked? So let's go ahead and remove all this, and I'm going to go ahead and just get rid of this as well. And we're just going to stick with the money one. So we know money is locked. We try to reassign money to even just none. That gets protected as we normally expect. However, what if we wanted to delete the money attribute? What actually happens? So if we run this, the code ran successfully, which means more than likely the money attribute was deleted. Let's find out. We actually print, and let's just simply print the maci data object. We should be able to see that money no longer exists. right? It's no longer an accessible attribute name. In fact, if we just type money here to try and access it, we're going to get an attribute error because it no longer exists. So if we did it before, it works, right? Before the deletion, but after the deletion, it no longer exists. So that brings me to the next locking method, which is hard lock. Now the hard lock, as you can imagine, gives you an even higher level of hardened protection against your attribute name, which really is just adding the ability to protect from deletion. And just to read from the documentation, attribute names that are hard locked cannot be reassigned to a new value, just like the regular lock. They cannot be unlocked or deleted. So you cannot unlock a hard locked attribute name. Keep that in mind. And of course, you cannot delete it. So you might be wondering, if I can't even unlock it, how are you ever supposed to change it? Well, the point of it is you're not. You're not supposed to change it at all. As soon as an attribute is hard locked, it is permanently locked throughout the runtime of the code. In fact, the only way to remove it is to delete the entire maci data object entirely. This was an intentional design if you wanted to create a very hardened attribute name that is fully protected through the runtime of the code. Hopefully that makes sense, but if there is an attempt to try to reassign it, unlock, or delete it, just like before, an exception will be thrown. And of course, attribute names must exist in order to lock them. And just as an example, I forgot to show, if the attribute name doesn't exist, so if I did like money1, maci will throw an exception and says locked attribute name does not exist, must be created first to lock. But let's go ahead and hard lock the attribute name this time and see how that behaves. So I'm going to go ahead and simply update this to hard. Oops, lock. And then we're going to change this to money. And now, if we try to delete this attribute name, it's going to throw an exception. As you can see down here, it says attribute name hard locked cannot be reassigned, deleted, or unlocked. And it tells you which attribute name that was. And same behavior, if I try to reassign it to a new value, it's going to give me the same exception. And as you can imagine, we try to use our try block. Same exact behavior. Oops. If we try to catch the exception, the value will remain the same, which is 1000 in this example. So again, you will not be able to change this if you try to unlock it. Let me show you what happens when you try to unlock it. So if we go unlock attribute, do money, maci's actually going to throw you a completely different exception, and I'll explain. So let's run it. Unlock attribute name does not exist in lock, could not find name to unlock. Maybe you already understand what it's saying, but the unlock method doesn't even look for attribute names in the hard lock list behind the scenes because it's only designed to be paired with the other lock. So hopefully that's understood. And now, just like the other lock, there is also a partner get method in order to actually view current state or current list of hard locked attributes. And you simply just type get hard lock list, and that'll do exactly the same thing as the other one did and return a list of hard locked attributes for you to view as well. So hopefully this makes sense so far. There is a couple of unique things to point out, to watch out for. The first one is, as mentioned earlier, if you try to lock an attribute name that's already locked using a different lock, it's going to throw an exception, because you cannot have two or more locks on a single attribute name. You can only have one or the other. So if I quickly try and relock this using the other lock and try to run this, we're going to get an exception. It says attribute name exists with other lock, hard lock adder already, cannot be locked with multiple locks. And of course, if you invert this, it'll give you the inverted message telling you that it's already been locked with lock adder. So that's something to keep in mind. You can only have one lock at a time on an attribute name at this time. Another thing I want to quickly show is if you try to lock an attribute twice, it's going to give you a different message and says that it cannot be relocked once locked. So just keep that in mind. Once a lock is applied, you cannot lock it again. Now, the second thing I want to talk about is updating an object that is mutable. Now, this concept might be a little bit more advanced, but I'm going to lightly explain it. But I highly recommend learning about the difference between mutable objects and immutable objects. So I'm going to go ahead and remove the regular locks here and just stick with the hard lock, because that's going to be the most hardened example. So currently, if we hard lock our money attribute, we get our value, which is 1,000, but as we know, we can't delete this attribute or reassign it. So now I'm going to quickly change this value to a mutable object, which is a list. Currently, we are referencing a float number, and that's an immutable object. An integer is also an immutable object, and a string is also an immutable object. And the simple understanding with those is that they have to be reassigned in order to get an updated value. So with this, I'm going to change this to a list. I'll just put 1, 2, 3 in there. And a list is a mutable object. So I'm going to go ahead, let's comment this out. I mean, that actually won't cause a syntax error at all, but we'll just run this. So now we have our list. We assigned it to a list. We locked the attribute name. So it is a list, but can we update this list even though it's hard locked? And the answer is yes. So I'm going to go ahead and update the first value, and we'll just set it to 100. So now if I run this, you see now the first element in the list got reassigned to 100. And you might be wondering what's going on. So very important to understand, which is also mentioned in the documentation, is that the locks only protect the attribute names. They do not protect the actual values. And I believe this was mentioned in the language section as well. The values have no protection at all. It's the attribute names themselves that are being protected, because right now we're not updating the attribute name, we're actually updating the object that the attribute name is assigned to, which is a list. So we're actually updating this list, we're not even touching this attribute name. We're not deleting an attribute name, we're not reassigning the attribute name to a new value. We are simply updating this mutable object to a new value. So that's something to keep in mind and understand, that mutable objects can still be updated, and that's by design. That behavior does not go away when using the hard lock. But if the object happens to be an immutable object, like a tuple, for example, that would be protected because you would have to reassign your attribute name to a new value. This is right now assigning the first element of the list to a new value, not the attribute name. So hopefully that makes sense and is understood. And lastly, I actually want to show you that these features are consistent within the maci structured data file as well. So using our simple example here, let's go ahead and dump our data to a file. Okay, so I've gone ahead and set our money attribute back to 1000. And I just simply created a string called game.save, and now we're going to dump our data to that file name, which is going to create a new file with our new maci data. And what you're going to notice is that the locking glyph, which is the hard lock glyph, is going to be stored in the file. So let's go ahead and run this. And so we see that new file called game.save was created. Let's go ahead and open it, and we'll move it to the side so we can see it here. Close that. And so, as you can see, our attribute names that we created and our values got safely stored to this file. But what you'll notice, like in the language section, we see this hard lock glyph was stored to that value. So when we actually go to load back our data, then maci knows that this attribute name is supposed to be hard locked when it's loaded back in. And so let's go ahead and do that. We'll go ahead and comment out our dump line here, and then we'll go ahead and just load that data back in, and we'll just call it new data for now, and we'll just say maci.load, and then we'll grab our file name variable, and now we'll go ahead and print it first just to kind of show it. So we're going to print our new maci data here, which is the same data we see when we run it. You see it loaded and it loads the same data that we see in this file. But now if we actually run the get hard locked list, you're going to actually see that money was set to hard locked and that it exists in this hard lock list. So again, as you can imagine, if you try to change the money value inside of your code after it's been loaded from the file, maci is going to throw that exception. And of course, this was hard locked, so that's actually going to be protected against deletion as well. So hopefully that makes sense. But as described in the language section, you can go ahead and express your attribute names in the file as well with these special glyphs to add these features to your attribute names. And of course, maci is smart enough to retain the state of those attribute names, whether they were locked or hard locked, and even mapped when we get to that video, and that'll be safely stored back to your file, remembering what state it was last left in. All right, so that's going to go ahead and wrap it up for this video on locking. Hopefully these features will be useful to you and the understanding made sense, but thank you so much for watching, and take care.